Okay, so the next question is a sample size question rather than a power question. So the same sort of calculation, but now we want to know the sample size and not power. Um, and we're still doing a z-test, still doing 5% error rate, and so on. In this case, we're testing h naught mu equal to 0 versus ha mu greater than 0. Typing on a tiny little keyboard here. And the standard deviation is given to be 0.04, and the power that we want is 80%, so the power is 80%, and the value of mu under the alternative, so let's call it mu a, is 0.01. Okay, so that's the information given. I'm going to hit return. It's going to give me an error, of course. So let's talk about when we would reject in this problem. So under the null hypothesis, my mean volume loss is normally distributed because we're doing a z-test. So our mean is going to be normally distributed with a mean of normally distributed with a mean of 0 and a standard deviation of 0.04 divided by square root n. Okay? Again, that's valid R code, but not terribly useful R code for us. And so when are we going to reject? We're going to reject if m is out in the tail of that distribution, and we'll reject if it's out in the 5% tail. So we're going to reject if m is greater than 0 plus q norm, well, let's just do it, the 95th percentile, which is 1.645, times 0.04 divided by square root n times the standard error. Okay, so we're going to reject if that's the case. Again, I don't have valid R code here because I haven't defined anything, but I'm just using this to describe the problem before I actually start typing out the real code. Okay, so we're going to reject if m is larger than that, and now we just need to do is calculate this probability under the alternative rather than under the null. Okay, so let me just say right here what this number is. 1.645 times 0.04. So it's 0.0658. Okay? And so let's just assume, for example, n is 10. Okay, so now n is 10, and I want to do p norm, okay, the probability that we reject, right, which in this case we said we're going to reject if we're larger than 0.0658 divided by square root n, and our mean under the alternative is 0.01, okay, and our standard deviation is equal to 0.04 divided by square root n. And remember, we're doing the greater than test, so we want to do lower dot tail equals false. Okay? So that would be 19% if n was 10. What if it was, let's say, 1,000? Okay? Okay, then the power would be 1. Okay, so we know that we need an n somewhere between 20 or between 10 and 1,000. Let's just almost half it and do n is 500, okay? And then it's still at 99%. So we know that now it's got to be between 500 and 10. Okay, so let's try 250. Okay, and let's get our power. Okay, and that's still pretty close to 1. So we still know so now we know it's between 250 and 10. Okay, so let's look at 125. Okay, and that's not bad. That's pretty close. So let's not half it again. Let's drop it down to 100. Okay, and wow, that's pretty close to 80%, the 80% power that we're shooting for. Okay, now let's try it. Let's try it at 99. Oh, that's really close. Let's try 98. Okay, oh, that's below. Okay, so we know that when n goes from 98 to 99, we jump, our power jumps from to over 80%. Okay, so we always round up for power, and so we want 99. So if I click 99, it'll submit. This is not the way in the solution to the problem I show you how to do this. The solution in the problem goes through a lot of normal manipulations, but I wanted to show you how to do this here just so you could you could see that you could logic your way through this without even writing a for loop. You could, of course, just written a for loop and drawn a graph or something and seen where it goes. But just to show you that, the intuition behind what you're doing. In the solution on the lecture notes, I show, exactly how you can solve for n with an equation. Okay, but here this is the more the intuition about what's going on.